Hey everybody, in this video we are graphing the polynomial you see on your screen. Hopefully you already watched the other video. I am graphing y equals x cubed minus 4x because I go into a breakdown of the sequence of steps that I like to do, and I also do a side explanation of what local behavior is and how to determine it. So if you don't know about local behavior, I would definitely recommend you start with that video before you dive into this one. And assuming you've done that already, let's get started. And Dallas says hi. He's hanging out today. Hey. So, little extra puppy support. Here we go. So I have y equals negative x to the fifth minus 6x to the fourth minus 9x cubed. If you have written the steps down and you know the steps and are familiar with them, we should know that the first thing that I like to do is to determine the end behavior. So the leading term of this polynomial is negative x to the fifth. So that means that the end behavior, for starters, the negative implies the right side is pointing down, and the odd degree starts in the opposite direction. So it's up and down is how we would describe this end behavior. So if we were super zoomed out and just looking at the graph, like what we would notice for sure is it's pointing up on the left and it's pointing down on the right. Any other fun activity we might not be able to see if we're too zoomed out. So E for end behavior is the first thing we do. The next one, F, if you know what it stands for, again, it's from the first video. So we are going to factor. So we will have y equals, I'm going to start off by taking out the greatest common factor, and if it's a negative leading term, I will certainly pull out a negative with the GCF, and if you don't, I don't know what to tell you. Why are you being weird? Just stop being so stubborn and just factor out the negative. Like, just do it. Stop not doing it, because then you mess up factoring. And then I have to explain to you what you did wrong. Like, just buckle up and let's go, right? Put on your big boy and big girl shoes and let's do this. So we took out the negative x cubed, and now you have x squared right there, dividing this out of all three places. This becomes a plus 6x and a plus 9. At this point, if you are graphing polynomials, it is beyond time for you to have no problem factoring. If you're struggling, you gotta go get help. You gotta go to extra help. You gotta do something. I don't know what to tell you. You got to get help, okay? Okay, let's go. Next up, y equals, we can factor this quadratic trinomial a little bit more. So I still have the negative x cubed. This ends up being x plus 3 times another x plus 3. I'm not going to go into it. If you need help factoring, go check my factoring playlist, watch some videos, do some practice, put down the calculator. Now, this negative x cubed could also be looked at just as a one-time explanation. That's the same thing. It looks doofy, it looks weird. It's not necessary to write it like that, but some of you might need to see it like that. And then this x plus 3, since I do have two of them, it would make more sense to write it like this. So this is all very, very beautiful and helpful. Is this part necessary? No, it's kind of weird. Is this one? Yeah, you should do that. This is fine right there, whatever. Next step, Z. Zero product property. You're going to set, and it only matters to do the inside because you would take the cube root or the square root of both sides anyway, and it's already equal to 0. So like, you don't need to set the whole entire package with the parenthesis and the exponent equal to 0. You could just jump ahead and go right to setting the inside equal, okay? So here I'm just gonna get x equals 0. Here, really you have x plus 3 equals 0, and then you subtract 3 from both sides, and you get x equals negative 3. So these here are your x-intercepts. Really, your x-intercepts should be written as ordered pairs. 0, 0, and negative 3, 0. I'm just, less is more right now. I'm just trying to get to the point. Now, A is for axes. Got it ready to go, okay? Then after A, we have label and local behavior. So local behavior and label. The local behavior is determined by, so we have our little baby x-intercept. Here it is. Here's 0. Here's negative 3. The local behavior, to figure out what is this little baby bird going to grow into, we got to figure out what kind of egg it came out of. So this came out of a cubing egg. This came out of a squaring egg. That means this is going to have a cubic local behavior, labeling it with a C, and this is going to have a quadratic local behavior. I'll label it with a Q. Now, local behavior L, that's the L step, but also label on here, okay, as well. And we're going to plot and label because the next thing is P. So we're plotting and labeling everything. So what do we got? I got 0 and I got -3. Here's 0. And that is a cubic behavior. Put a little C by it so don't forget. Then 1, 2, here's -3. And that one has a quadratic local behavior. Now, plot that point. What else do we have? Well, we also have our end behavior arrows. So somewhere over here, I'm going to have an arrow pointing down, and somewhere over here, I'm going to have an arrow pointing up, and I'm just going to have to make sure I somehow connect them as best as I can. Obviously, it doesn't all have to be the scale. I never put tick marks on my y-axis. The scale on the y-axis is always quite ridiculous. Just ignore it. Now, start on the right side. Why? Watch the first video. I explain why. Trust me. Insurance policy, okay? Your insurance policy. When I ask you, what's your insurance policy? You're going to tell me your insurance policy, start on the right side when you're graphing. That's your insurance policy. So again, what's our insurance policy? Start on the right side of the end behavior. So I'm going to work my way to that x-intercept. Now the C says what my local behavior is. C means cubic. I'm going to cut through here in a cubic behavior. And what does cubic behavior look like? Well, it looks like a little bit of a half a parabola on the right, frowny face in this case to match up with the end behavior, right? Because that's what matters. And then it's going to be an upward parabola on the other side. So it's going to be like cutting through kind of like linear, but more squiggly shape to it. Now it's got to be smooth and continuous. It's turning around. Remember, it's a function. It can't be over itself. Now I'm going to work my way back here. Now this could go very high. This could be a y value of 1,000,000. I don't know. Turn around. I'm going to touch here, and it's going to be a quadratic local behavior. That means you're not cutting through linear. You're not cutting through cubic, but you're going to get there and do a little bit of a U shape. Uh-oh, Dallas is not into it. You're going to do a little bit of a U shape here, and then we're just going to go ahead and finish up the graph. Arrow on both sides, implying it goes on and on and on forever in both directions. All right, so again, that little arrow I drew at first has like no use for me now, so I could just wipe that out. Is this the best looking thing I ever made in my life? Probably not, but is it correct? Yeah, you know, is that what really matters? Also, yeah. So I don't know where to squeeze this, but to fit everything on the screen, but here you go. Okay, so there we have it. This is your graph. Those are your steps. Oh, and the last step over here with the little letters was G for graph, and that's what we did. Okay, so there you have it. Beautiful, amazing. One of the best things you did all day. I hope you get it, got it. I hope you didn't draw your cubic behavior the wrong way. What everyone kind of does like that. Do you see that's not what that is? Not the same. It's like this in this case. Okay. You'll get it. It'll take some time. So for more help, if you need factoring, you got to go dig, find the factoring playlist, and you got to buckle down, because if you think factoring is hard now, this is only the beginning, my friends. You need to know how to factor. It's just a reality. Accept it. You got to know how to walk, tie your shoes, breathe. You got to know how to factor if you're going to take Algebra 2, if you're going to take pre-calculus, calculus, any of that. Like, you have to. Stop using your phone, equations, stupid solver, whatever the heck it's called, photomath. Put it down, okay? You're locking yourself in at a low level of ability. Knock it off. Let's go, okay? Click through for the next example. Sorry for my rant. Dallas is getting feisty because I'm getting feisty. He wants to play. Give the video a thumbs up. Give it a subscribe. Click through for the next one. Have a great day. Hope you're feeling smarter. Sorry I was being sassy. Just got a little fed up with the poor me, you know? Let's do it. Stop being poor you. You can do it. Adios.